number 3. So for number 3, the first thing we're going to do is we are going to label the information we're given. A is 8, C is 5, and angle B is 8 degrees. It's then up to us to determine what we want to find next. Do we want to find a side length next? Do we want to find an angle next? What are you guys thinking? Side B is the only thing we can find, right? And if we go back up here, which formula are we going to use? This one, or this one? The second one. They're all the same, but we're going to use the second one, okay? So in number 3, this would be B squared, which do we know what B is? No, so it's just B squared is equal to A squared plus C squared minus 2 times A times C times the cosine of B, which happens to be 8 degrees. Any questions here? Okay, where we're going to go from here is we are just going to plug this into our calculator, okay? So y'all do that while I do it up here, please. I am. So this is going to be 8 squared plus 5 squared. If you don't have a calculator, now is the time to get it. Times 2 times 8 times 5 times the cosine of 8. Did everybody get 9.8 or 9.78? So this is not our B, though. This is not what B is it? This is B squared, so we still need to take the square root. So press second x squared, and then second that negative sign. And that gives us that B is equal to 3.1 degrees. I'm sorry, not degrees, because that's not an angle, just 3.1. Any questions there? Okay, so now we have to ask ourselves, do we want to find angle A or angle C? What do y'all want to find? C. Right. Yes, no, you're absolutely right. Let's start with A, okay? So if we started with A, what is that going to give us? All right, 8 squared is equal to 5 squared the cosine of A, correct? Any questions? Okay, so now we can put this in our calculator. Patricia, you were asking me how to do this earlier, so please follow along. All right, so this is 8 squared. And then we know we want to subtract this 5x squared from both sides, right? So let's go ahead and do that in our calculator. And I'm going to do it here so you know it's gone. And then we want to subtract 3.1 squared from both sides. Get rid of that. Go ahead and press enter. Okay, next we want to divide by all of this, okay? And we can do that by dividing open parentheses. That open parentheses is very important. -2 times 5 times 3.1. Is that what you guys got? And your answer would be 161.5 or 161.5 degrees. Okay, now we need to find angle C. We could do the law of cosines again, but that would be annoying. How could we do this way easier? We know the sum of the 3 angles of a triangle is 180 degrees, right? So we can just, we know that this one is 161.5, and we know that this one is 8. So what does that leave us for angle C? Oh, y'all can't see that. I'm sorry, what? So just 180 minus 161.5 minus 8 tells us angle C, which is what? 10.5 degrees? All right, are there any questions here? Raise your hand if you have any other questions about your homework. Questions going once, questions go twice. All right, turn over on the back, please. Now, the back is no different, all right? The only difference in the back is we have to decide if we're using law of sines or the law of cosines. So if you look at example number 7, do we have enough what do we want to use? Law of sines, law of cosines, and why? We have to use law of sines, right? We have to. But with law of sines, we usually need, we have to have an angle and an angle opposite, a side opposite that angle, right?
Why do we have to use law of sines?
Because we can't use law of cosines because we only know one side. And in law of cosines, this is angle A, angle B, angle C in all different equations. We don't have enough information. But we can use law of sines, but not just yet. There's something we have to find before we can use law of sines here. And what is that something? Angle A. Can we easily find angle A though? Yeah. Angle A is equal to 180 minus our other two angles, right? So that means angle A would be equal to how many degrees? 65? All right, 65 degrees, that's not our answer, right? Our answer is what?
Law
Well, we have to use,
of B.
or what we're looking for is B, side B, right? But we needed angle A to find side B. So how could I set this up, Allie? Using law of sines here.
Sine
Mhm.
of 65 over n equals sine of 80 over n.
Very good. So now we would just cross multiply. And that gives us B sine of 65 degrees is equal to 10 sine of 80 degrees. Divide both sides by the sine of 65, and we get B is equal to 10 sine of 80 degrees divided by the sine of 65 degrees. And what is that equal to? 10.9? Any questions here? Is that pretty simple? It's just kind of a review of law of sines, right? Okay, let's go to number 8. Now, is number 8 going to be law of sines or law of cosines?
Cosines.
Law of cosines? Are you sure?
Yeah.
Okay. All right, what do we need to find first? Side B. Do y'all see that we have to find side B in number 8 in order for us to find angle C? Because for law of cosines, we really want to have all three of those sides. We have to have all three of those sides if we're looking for an angle. So to find side B, that would just be B squared is equal to 23 squared plus 20 squared minus 2 times 23 times 20 times the cosine of 119 degrees. All I did was plug this in to our law of cosines formula. And as y'all are typing, I will do that as well. 23 squared plus 20 squared minus 2 times 23 times 20 times the cosine of 119. Bless you. When you get this, did everybody get 1,375 and some stuff? When you got this, did you feel like you did something wrong because it's such a big number? No, because why? We still need to take the square root. B squared is equal to this, okay? But we're not looking for B squared, we're looking for B. So if we take the square root of that, we get 37.1. Does that sound about right for B? Any questions? Now that we know B, can we find angle C? Yes? Okay, so for angle C, we'll have C, which is 20 squared, right, is equal to 23 squared plus 37.1 squared minus 2 times 23 times 37.1 times the cosine of C. All right, is that what you guys got? Now let me know when y'all are ready to put this in your calculator. Ready? Right? Okay. So remember, we can just say 20 squared minus 23 squared minus 37.1 squared. Okay, so that's we got rid of this guy, we got rid of this guy. And now we just want to divide by what? Good, and this is what we got. And then we just want to find the cosine inverse of that. Did everybody get 28.1 as angle C? Yes? Any questions? Yes. Question? No? All right, any other questions on this? Do you think you can take it from here? We are, well, 119 is going to be the biggest angle, right? Right, 119 has to be the biggest angle, or this wouldn't be a triangle, right?
Like, wouldn't you do the next biggest? Like, is it biggest or smallest?
That's what you taught us on the other side of the page.
I don't think it's going to matter as long as you start with the biggest. After that, I think it doesn't matter. Does it make sense? And if it does, it's going to be maybe a few decimals off, just because we're rounding. What we really want to do is just get the obtuse angle out of the way first. Does it make sense? Yes? Okay. Look at, or any other questions on this page? Questions? Okay.
Which one do you like?
Thank you. All right, so now we are going to start reviewing your study guide. We can start with number 1. Who can tell me what the cotangent of theta is? Very good. Cosine of theta over the sine of theta.
We don't put theta in our work, is that wrong?
Yes, I need you to use theta, okay? I need to know that you're talking about the cosine of an angle, all right?
Wait.
Without theta, COS is just a cos without a T, yes.
Did we, I have a question.
Mm-hmm.
Did we do this stuff like, did we already have a test on this, or did
You had a quiz on this? You had a quiz to kind of assess what you knew and what you needed to work on, and then from that, we added stuff, which we've been doing, and now we're having a test on all of this. Is that clear?
Yeah, I just didn't know.
Okay. So cotangent is just cosine of theta over sine of theta, right? And then secant of theta is just what?
1 over
Cosine of theta, good. And then these two guys cancel out, and that just leaves us with 1 over the sine of theta. But what is 1 over the sine of theta equal to? It's just equal. Any questions? What'd you say? It did sound like thunder. All right, let's look at number 2. Number 2, in the numerator, that is a very special something that we call a trig. Or you're right, Pythagorean identity. Good. Those are my eyes. Sorry. Identity. Get it? Okay. Pythagorean identity. So what is it? What is this Pythagorean identity? What is the cosecant squared of theta minus the cotangent squared of theta equal to? 1, are you sure? All right. So this is equal to 1. All right. This is staying the same. So what's in the denominator? What is 1 minus the sine squared of theta equal to?
Cosine squared.
Okay. And what's 1 divided by the cosine squared of theta?
Secant squared.
And guess what we wanted this to be equal to? Very good. So we are done. Any questions? All right, number 3 is a little bit worse than you guys, a little bit worse than those first 2. So how can we rewrite the secant of theta?
1 over 2.
Good, and that's minus just regular old cosine of theta divided by, again, secant of theta is 1 over the cosine of theta, right? No. Excuse me. So now, reporting in. Okay, sorry about this. So what we need now is when we divide by a fraction, it's the same as multiplying by the reciprocal. When we divide by a fraction, it's the same as multiplying by the reciprocal. So, what is the reciprocal of 1 over the cosine of theta?
Cosine.
It's just regular cosine of theta. So we have cosine of theta. So this cosine of theta came from here. I just changed it to the reciprocal, and we're multiplying it times everything in the numerator, which is 1 divided by the cosine of theta minus the cosine of theta. All right, when I distribute this here, that gives us the cosine of theta divided by the cosine of theta minus cosine squared of theta. Okay, the cosine of theta divided by the cosine of theta, or anything divided by itself, is 1. So that gives us 1 minus the cosine squared of theta, which we know is equal by the Pythagorean identity to the sine squared of theta. And sine squared of theta is exactly what we wanted our left side of our equation to be equal to. Are there any questions? Okay. Let's look on number 4. On number 4, this is sine of theta, which we are going to leave as sine of theta. And the cosecant of theta, which we can rewrite as what?
1 over sine.
Very good. 1 over the sine of theta. We could multiply by the reciprocal, so that would be the sine of theta times the sine of theta, which is just the sine squared of theta, and that is equal to the sine squared of theta. Any questions here? All right, so now what we're going to do is we are going to distribute here. 1 times 1 is 1. 1 times the sine of theta is sine of theta. All right, any questions so far? So now we just want to simplify, and we get 1 minus the sine squared of theta. And what is 1 minus the sine squared of theta equal to? Cosine squared of theta, which is exactly what we wanted. Are there any questions? Okay, look on number 6. We want the left side to be equal to the secant of theta. Remember, we're going to try to write things just in terms of sine and cosine, okay? So this will just be the sine of theta. And then how can we rewrite the tangent of theta? Sine of theta over the cosine of theta plus cosine of theta. And we know that the sine of theta times the sine of theta is just the sine squared of theta. Okay, and what do we need to happen now? Maybe when you get to this point, this is where you get a little confused, but what needs to happen here? We need to have common denominators. Very good, which means we need to multiply the numerator and denominator here by the cosine of theta, right? And the left side stays the same, but the right side becomes cosine squared of theta divided by cosine of theta. And now that we have common denominators, we can combine our numerators, which we can't really combine them. But this becomes sine squared of theta plus cosine squared of theta all over the cosine of theta. And what's in the numerator? What is sine squared of theta plus cosine squared of theta?
1.
I'm sorry. I was saying what's sine squared of theta plus the cosine squared of theta? It's a Pythagorean identity, and it's 1, right? Do you remember? Murphy, I know you said it. There are other people. I just wanted to make sure they heard it too, okay? So that's 1 over the cosine of theta, which is just the secant of theta. Any questions here? Do we feel okay about this? Do we remember this? Okay, look at number 7. On number 7, the secant of theta is just 1 over the cosine of theta. This one's kind of easy, right? Because at this point, we can just multiply by the reciprocal of the denominator. So we have 1 over the cosine of theta times the reciprocal of 1 over the sine of theta, which is just the sine of theta, over 1. That gives us the sine of theta divided by the cosine of theta, which is what? The tangent of theta, which is equal to the tangent of theta, which is exactly what we wanted. I know I'm going kind of fast, but I want to get through as many problems as possible, if not all problems. I'm not going to do too many from 8 to 18 because I feel like they're very similar to these, besides the fact that you're not just given the answer. Are there any ones looking through that section, 8 to 18, that you specifically would like to see worked out? Any ones in that section at all? 8 to 18. 16, okay. All right, I can show you 16, Griffin, and I'll show you in terms of sine and cosine, but if you just thought about it, what is anything times its reciprocal? Like, what is 6 times 1, 6? 1. What is 1/5 times 5? But I will work this problem out still because some people, I know you don't need it, but I think other people who didn't see that might need help here. So we could break this up into the sine of theta over the cosine of theta. And I'm just going to go ahead and multiply. Cotangent is the cosine of theta times the sine of theta, or divided by the sine of theta, I'm sorry. So that's this. Now we distribute it here. What happens with our sines and our cosines? We just get 1. And what is the sine squared of theta divided by cosine squared of theta? Right, and what is 1 plus the tan squared of theta? Good. Any questions there? Yes, sir.
Number 10, you have a negative.
Yes. And that's, number 10 is tricky because you guys see a 1 and you see secant squared of theta and you automatically just write down tangent squared of theta. But that doesn't mean it couldn't be negative tangent squared of theta. And on number 10, it actually is negative tangent squared of theta. It's the of secant, it's the tan of theta, tangent squared of theta plus 1 is equal to secant squared of theta. So to get that secant negative, we've got to subtract it and then subtract the tangent squared of theta. All right, other questions from 8 to 18? Okay, let's look on the back. I want to go over some of these problems with you guys when we're solving. Let me see which ones I think I want you guys to work. Yes, I'll be here tomorrow. Let's look at number 22. Okay, on number 22, the first thing we want to do here is we want to subtract 3 from both sides. And that leaves us with 4 sine of theta is equal to negative 3. And then we want to divide both sides by what? 4. Good. So then we have the sine of theta is equal to negative 3/4. So from here, we just want to find out what theta is. Do you guys remember how to find out what theta is? Sam. Right. We do the sine inverse. Theta is equal to the sine inverse of negative 3/4, which is what? Negative 48.6 degrees, right? So now we want to draw our coordinate plane, and remember that all students take calculus. Our theta has to be by the directions, John. Our theta has to be between 0 and 360, okay? If we're going negative 48.6, that's going to be somewhere around here. So our reference angle is that's not true. Our reference angle is 48.6 degrees, right? It has to be positive. So to find our theta, it's in the fourth quadrant, so it's just going to be 360 minus our reference angle, which is 48.6 degrees. And how many degrees is that going to give us for theta? I can't hear you. 300 and what? So that's one answer, okay? Now, is our sign, is it positive or negative? We want it to be negative, right? So, what other quadrant is the sign negative in? We would just add it to our reference angle to 180 degrees. And that gives us theta is equal to what? 228.6 degrees. Are there any questions here? Okay, let's go down to 26. All right, on 26, what are you thinking you want to do here? Okay, distribute. We could do that. Is there something else we could do? All right, let's distribute. What? Go ahead, say it, please. All right. It will be, I don't think, we're solving here, right? We're solving. So we could distribute, or couldn't we just go ahead and just set both of these factors equal to 0? So we could do either one, right? Hey guys, can you hear me? We could do either one. Do you understand that distributing would give us the same answer? If we distributed, we'd get cosine squared of theta minus 1. We'd add 1 to both sides and then take the square root. So we'd have cosine of theta is equal to plus or minus 1, which is what we're about to have here. Because if we subtract 1 here, that gives us the cosine of theta is equal to negative 1, right? So theta is equal to the cosine inverse of negative 1, which is what? Which is what? 180? All right, and on our graph, if we look, we know this is 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Only at this one point right here at 180 degrees, only at this angle, 180 degrees, is our cosine ever going to be negative 1, okay? So theta is equal to 180 is the only solution to the cosine of theta equals negative 1. Now, we might have a different answer for positive 1. Let's see. If we add 1 here, that gives us the cosine of theta is equal to 1, right? So then theta is equal to the cosine inverse of 1. So what would theta be equal to? 0 degrees. But if theta is 0, what else is... right, theta is also equal to 360 degrees. And are there any other points where our cosine is going to be positive 1? No, right? Yes, cosine's first, and you can remember that because sine's second. Sine second, sine second, okay? But what? Up top, the cosine is 0. We're talking about cosine's the first one. So we want cosine to be negative 1 and 1, and that only happens here and here. Do you see now? Okay. Questions? All right, let's look at number 27. On number 27, what's the first thing we want to do here? Subtract what? Sine of theta from both sides. A lot of you guys in your tests on problems like these, on your quiz, you tried to divide both sides by the sine of theta. So that gives us sine squared of theta minus the sine of theta
Why can't you divide?
is equal to 0, because then you're dividing out a solution that you forgot you had. It's like if we had x squared minus 3x equals 0. Our two answers, if we factored out at x and we got x minus 3 equals 0, we have two answers, and that's that x is equal to 0 and that x is equal to positive 3, right? But if we had it written as this way, and we divided both sides by x, then we just get x equals 3. We'd forget the whole fact that the denominator cannot be equal to 0. Did that answer your question? Yes? All right. So any questions so far? Let's set one side equal to 0. Now we're going to have to factor out a what? GCF, which is the sine of theta, right? And that leaves us with the sine of theta minus 1 is equal to 0. So now we just set both of these factors equal to 0. And when you put the sine inverse of 0 in your calculator, what'd you guys get? 0? Okay, but let's look at this. Okay, so we know that the sine is 0 at 0 degrees, right? So we know theta is equal to 0, but if it's 0, what else is it? Theta is also equal to 360 degrees, right? Are there any other places where the sine of theta is 0? At 180 degrees as well. So theta is equal to 0, 360, and 180. And that's that. Remember, we've talked about that one a lot, about how we've done sine of 0 so many times, haven't we? Or sine of theta equals 0 so many times. Now over here, when we add 1, that gives us the sine of theta is equal to 1. Okay, and where's the only, or I guess we can put this in our calculator. 90 is the only, at 90 degrees, that's the only place where the sine of theta is positive 1. And you can see that here. So those are our, those are our 4 answers. Any other questions on number 27? Okay, I really want to go over problem like number 30 with you. Okay, if you look at number 30, we would add 2 to both sides, right? And that gives us the secant of theta equals 2. But you guys kind of pause and you say, oh man, I don't have a secant button on my calculator, right? So what we can do is we can write secant in terms of, it's inverse, which is what? I'm sorry, it's reciprocal, what's its reciprocal? 1 over cosine of theta, right? Or we could say the cosine of theta is just equal to 1 over the secant of theta. So that's the cosine of theta is equal to 1 divided by 2. Do you guys see that? So from this point on, all we have to do is find theta. Oops, not sine. Okay, and what's the cosine inverse of 1/2? Is that 60 degrees? All right, so when we graph this, after remembering that all students take calculus, 60 degrees is here. As 60 degrees is also our reference angle. Okay, so where else is our cosine positive or negative? Positive. Where else is our cosine positive? 4th quadrant, right? Because this C stands for a cosine, only cosine is positive. And since we're in the 4th quadrant, we know that theta is just going to be equal to 360 minus our reference angle, which is 60 degrees. That leaves us with theta is equal to 300 degrees. Are there any questions? Please listen to this before you pack up. Today is the last day I will have after-school tutoring for you to attend before this test. So if you are struggling with any of this and you need to come to tutoring, you need to come see me today. I will also have videos on Schoology which you can watch. If you borrowed a calculator, please put it back in the calculator caddy. Daniel, calculator caddy, please.